Okay, so let's dive right into this, shall we? You sent over some really interesting stuff about Google's Spanner database,
Right.
and it's obviously not your average system.
Yeah.
We're going to explore how it kind of went from like a simple key value store to this globally distributed SQL powerhouse
Yeah.
that apparently powers thousands of Google services.
Yeah. It's a really fascinating journey. And what I think is particularly interesting is how um, Spanner's design really emerged from the limitations of what came before it.
Okay.
I think it's easy to think that NoSQL solves everything when you need to scale.
Right.
But Google's experience with systems like Bigtable really kind of shows that that's not always the whole story.
Yeah, and even with NoSQL's flexibility, the paper mentions that Google developers, they ran into some roadblocks when they tried to build applications on top of
I
Bigtable. They
relate.
were kind of more complex.
Exactly. Imagine you're trying to build something like, I don't know, like a banking system where accuracy is super critical,
Right.
but your underlying data store doesn't have a strong schema.
Okay.
It'd be a nightmare to try to ensure data consistency and prevent errors.
So, like, no way to enforce relationships between different pieces of data,
Yeah,
like guaranteeing every transaction is tied to a valid account.
exactly. That lack of structure can just lead to all sorts of problems, and
Right.
and that's just one issue.
Yeah.
Think about transactions that need to span multiple rows.
Yes.
Super common in online systems.
Right.
Key value stores just weren't designed for that.
Okay.
And then when you add in the need for consistent replication across multiple data centers,
Yeah.
things just get even more complex.
Oh, I bet. The developers must have been pulling their hair out.
Yeah,
So no wonder they were craving a more powerful and reliable way to manage their data
totally.
with a query language that didn't feel like using stone knives and bearskins.
Yeah. And that desire for both robust structure and a massive scale is kind of what led to Spanner's transformation
Okay.
from a humble key value store into this full-fledged SQL system.
Okay, that's quite the leap. So before we get into how they pulled that off,
Yeah.
I think it'd be helpful to um, maybe define a couple of key terms for our listeners.
Yeah, for sure.
We're talking about globally distributed databases,
Right.
data sharding, Paxos. That's a lot to unpack.
Yeah, absolutely. Let's break it down a bit. When we say globally distributed, we're talking about data spread across multiple data centers,
Yeah.
possibly even continents.
Right.
This is like essential for resilience.
Okay.
If one data center goes offline, your data is still accessible.
Makes sense.
But managing this distributed data, that's where things get a little interesting.
Yeah, that's where data sharding comes in. Right?
Exactly. Sharding is basically like cutting a pizza into slices.
Okay.
Each shard is a portion of the database.
Okay.
And these shards are replicated across different data centers.
Right.
That way, if one slice disappears,
Right.
you still have other slices with the same information.
Makes sense.
Yeah.
But now you have all these pieces kind of spread out. How do you make sure they all stay consistent when, like, updates happen?
Right.
That's where this Paxos thing comes in.
Right. Think of Paxos as like a super reliable messenger
Okay.
that ensures all the replicas of a shard agree on the order of updates,
Okay.
no matter where the update originates.
Right.
This is vital for maintaining data consistency
Okay.
across the whole system.
So Paxos is the glue that holds it all together.
You got it.
Okay. But I'm imagining, like, all this coordination must get insanely complex when you start talking about queries that span multiple shards,
Yeah.
especially with updates happening all the time.
You're absolutely right. That is a huge challenge, and it's one that Spanner addresses with its distributed query processing capabilities,
Okay.
alongside some clever techniques for concurrency control.
Concurrency control. What's that mean? Like preventing traffic jams in the database.
Essentially, yes.
Okay.
It's about making sure that multiple users can read and write data at the same time without creating conflicts or inconsistencies.
Right.
Spanner uses a combination of two-phase locking and timestamps to manage this.
Okay.
It's like a well-choreographed dance,
Yeah.
ensuring that every transaction sees a consistent view of the data,
Right.
even as updates are happening all over the place.
Gotcha. Okay, so I think I'm starting to grasp the complexity here.
Yeah.
But let's talk about those queries that span multiple shards.
Sure.
How does Spanner actually handle that?
So Spanner has this special operator called distributed union,
Okay.
which acts kind of like an orchestra conductor,
Okay.
coordinating the execution of a query across all the relevant shards.
Okay.
It breaks down the query into smaller pieces,
Right.
sends them to the right places, and then gathers the results.
So it's like a divide and conquer strategy, but for data.
Precisely. And Spanner also utilizes some clever optimizations to minimize latency,
Okay.
like shard and server affinity.
Okay.
If a shard is available locally, Spanner will just execute the query right there,
Right.
avoiding unnecessary network trips.
That's pretty smart. But what about joins? Those are pretty expensive in database systems,
Absolutely.
especially when you're dealing with data spread across multiple shards.
They are.
Yeah.
And Spanner tackles this head-on with its distributed apply operator,
Sure.
which processes them in batches across different shards,
Okay.
significantly reducing overhead compared to handling each row individually.
So it's like bulk shipping instead of like individual packages.
Exactly. And this batching is incredibly efficient, especially when you consider the massive scale at which Spanner operates.
Right, right. It's mind-boggling. But even with all these optimizations, sometimes you need to process truly gigantic data sets.
Yeah.
Does Spanner make you download all that to your own machine?
Thankfully, no. It provides a parallel consumer API specifically designed for large-scale data processing.
Okay.
This allows multiple processes, potentially running on different machines, to consume the query results in parallel.
So it's like having a team of movers, each carrying a portion of your furniture.
That's a great analogy. This parallel processing is a game changer for tasks like combining Spanner data with external data sets or running complex transformations.
Gotcha. Okay, now I'm really starting to see how Spanner achieves such impressive performance,
Good.
even with all this data spread across the globe.
Yeah.
But I'm curious, how does it actually know which each data to access for a given query? Is it just blindly searching through all the shards?
No way. That would be like trying to find a needle in a haystack the size of a planet.
Right.
Spanner uses this technique called query range extraction to pinpoint exactly which data is needed.
Query range extraction.
Yeah.
That was pretty complicated.
It's actually,
Can you break it down for us?
imagine you have a library with millions of books,
Okay.
but you only need a specific chapter from one book. You wouldn't want to search every shelf. Query range extraction is like having a super efficient librarian who instantly knows the exact location of the information you need.
So it figures out which shelves to look on.
Yes. It analyzes the query and determines the relevant data ranges, preventing unnecessary data scans.
Gotcha, gotcha. So it's all about being super focused,
Yes.
especially at Spanner scale where every bit of efficiency counts.
Exactly. And it achieves this through some clever techniques,
Okay.
including rewriting queries at compile time
Right.
and using this special data structure called a filter tree to compute ranges and apply filters efficiently.
So I get the big picture. Efficiency is key.
It is.
But even with all this meticulous planning, things can go wrong.
Oh, of course.
Servers can fail. Networks can hiccup.
Sure.
Data can move around during resharding.
Yeah, absolutely.
So how does Spanner handle all this?
That's where query restarts come in.
Okay.
Imagine you're watching a movie
Yeah.
and the power goes out. You wouldn't want to start the movie over from the beginning. Right.
Definitely not.
Exactly. Query restarts are basically like hitting the resume button for your query.
Okay.
Spanner keeps track of its progress.
Right.
So even if there's a failure,
Yeah.
it can just pick up right where it left off.
Oh, that's a huge relief.
It is.
It must save developers a ton of time.
It simplifies the programming model,
Right.
and it makes Spanner incredibly resilient.
Gotcha.
And it's not just about handling failures.
Yeah.
Query restarts also enable some really cool features,
Like what?
like efficient streaming pagination and improved tail latency.
Streaming pagination. Is that like reading a long book chapter by chapter?
Precisely. You only download the data you need at that moment, making it much more manageable for large data sets.
Okay.
And improved tail latency means faster responses,
Right.
even when the system is under heavy load.
Okay, I'm seeing the pattern here. Spanner is obsessed with speed and reliability,
It is.
even when unexpected things happen.
It's all about those guarantees.
But this whole query restart thing, it sounds pretty complex to implement.
It is. Handling dynamic resharding, where data moves around, presents a big challenge.
Right.
Spanner needs to be able to figure out where the data went
Okay.
and pick up where it left off.
Right.
It's like solving a puzzle where the pieces keep changing positions.
Sounds like a logistical nightmare.
It is. And on top of that, you have to deal with with non-determinism in query execution,
Yeah.
meaning the order of results might vary depending on things like server load.
Right.
Spanner uses various techniques to ensure that the results are still valid,
Okay.
even if they're not returned in the exact same order.
So it's like making sure your save game works even after you update the game.
Exactly. It's a testament to the Spanner team's engineering prowess.
They've clearly thought this through.
They have.
Yeah, okay. Query restarts, game changer.
For sure.
But let's shift gears for a moment.
Okay.
The paper also mentioned something about a common SQL dialect. Does Spanner have its own secret language or something?
Not exactly a secret language,
Wow.
but it is fascinating how Spanner shares a common SQL dialect with other Google systems like F1 and Dremel.
Okay.
They call it standard SQL.
Okay.
And it's kind of like a universal language for data within Google.
Ah, so no more dialect confusion.
Exactly. It's like having a single passport that grants you access to a vast world of data.
Right.
This shared dialect makes it much easier to learn new systems, integrate them,
Right.
and to share knowledge and skills.
I bet the data analysts are happy.
I'm sure they are.
But how did they get everyone on the same page? Is there a big SQL conference or something?
Something like that.
Yeah.
They put a lot of effort into defining a common data model, syntax, semantics, and even a shared function library.
Okay.
They created these shared components like a compiler front end
Okay.
to make sure everyone is building their SQL systems
Right.
with the same tools and following the same rules.
So it's like a standardized recipe book.
Exactly.
Everybody's cooking the same dish.
Yeah.
Right.
And to make sure everything works as expected,
Right.
they have this comprehensive testing framework
Okay.
that runs both compliance tests and coverage tests.
Okay.
They even use a random query generator to catch any potential inconsistencies
Right.
or deviations from the standard.
Wow, they really thought of everything.
They try to.
It sounds like a well-oiled machine.
It is.
Speaking of which, all this talk about SQL and queries, it makes me wonder about Spanner's underlying storage.
Sure.
Is all this data stored in one giant file somewhere in the Googleplex?
That would be one enormous file.
Right.
So Spanner actually uses a sophisticated approach.
Oh.
And it's evolved over time. Originally, it relied on S-tables, which
Okay.
are sorted string tables inherited from Bigtable.
Tables, those are like structured flat files.
Yeah, you got it.
Good for some things,
Right.
but maybe not ideal for handling massive SQL workloads.
That's exactly right. And that's why they introduced Ressi, which is a new low-level storage format designed specifically for handling SQL queries at scale.
Ressi. Sounds cool. What's so special about this new format?
Well, for one, it uses a blockwise-columnar data layout, meaning data is organized by columns instead of rows.
So it's like flipping a spreadsheet on its side.
Precisely.
That's clever.
It optimizes for queries that target specific columns.
Right.
But of course, there are trade-offs.
Yeah.
But overall, the benefits for SQL workloads outweigh the drawbacks.
Okay.
Ressi also segregates active and inactive data,
Okay.
as well as large values, further optimizing I/O efficiency.
Okay, so it's all about finding the right balance for the specific use case.
Exactly.
But switching storage formats for a system as massive as Spanner.
Yeah,
It sounds a little bit like changing a tire on a moving car.
it was definitely a challenge. They had to migrate from S-tables to Ressi without disrupting ongoing user workloads,
Right.
which involved careful planning, gradual rollout, and lots of testing to ensure data integrity.
So it's like it's a delicate operation.
It is, but it shows their commitment to continuous improvement.
Yeah, they definitely don't shy away from tackling tough problems.
They don't.
I'm impressed. But, with all these technical details,
Sure.
it's easy to lose sight of the big picture.
Yeah.
What are some of the key lessons they learned while building and deploying Spanner?
That's a great question. One crucial takeaway is the importance of horizontal scalability.
Okay.
From day one, Spanner was designed to grow effortlessly across a vast number of machines.
Okay.
No matter how much data you throw at it, it can handle it.
So it's like a data sponge, just soaking it all up.
Exactly. Their experience also highlighted the increasing value of SQL.
Yeah.
While no SQL databases have their place, SQL's expressive power and familiarity are really crucial for building complex applications.
So it seems like SQL's making a bit of a comeback,
It is.
even in the world of massive distributed systems.
Yeah, it's not going anywhere.
But even with Spanner's successes, there must be some challenges that still lie ahead.
Absolutely. One area they're exploring is supporting read-your-rights semantics within transactions.
Okay.
Currently, Spanner requires all updates to be committed at the end,
Right.
which can be a little limiting in some scenarios.
Okay, so they're trying to make transactions even more flexible.
Exactly. And of course, they're always working on query optimization.
Of course.
Finding the most efficient way to execute complex queries across a distributed database
Right.
is a never-ending quest.
Like searching for the holy grail of query performance.
You could say that. And they're also looking at ways to combine OLTP, OLAPI, and full-text search capabilities within a single system.
So like a true unified data platform.
It is, but given Spanner's track record, I wouldn't bet against them.
Right, right. They've consistently pushed the boundaries.
They have.
It's pretty amazing what they've accomplished.
It is.
But before we move on, the paper mentions this thing called a coprocessor framework, almost in passing.
Ah, yes.
What's that all about?
Coprocessors are a fascinating aspect of Spanner.
Okay.
They give it even more flexibility.
All right, now you've piqued my interest. Unfortunately, we're out of time for this segment. We'll have to dive into that fascinating topic in part 2 of our Spanner deep dive.
Sounds good to me. So coprocessors, they're really a fascinating aspect of Spanner.
Okay, remind me, what are these coprocessors exactly?
Okay, so
You made them sound like some secret ingredient that makes Spanner even more powerful.
yeah, so think of it this way. Spanner handles all the heavy lifting of data distribution and replication and
Yeah.
keeping everything consistent.
Okay.
But what if you need to do something kind of specialized?
Like-
Something that goes beyond the standard SQL features?
So Spanner provides the basic tools,
Yeah,
but sometimes you need to bring your own custom gadgets.
exactly. And that's where coprocessors come in.
Okay.
They let you run custom code right there on the servers where the data lives.
So it's like having a workshop attached to your lumberyard. You don't have to haul all that wood around.
Oh, that's a great way to put it.
Clever.
Yeah, and it's much more efficient than pulling all the data back to your own machine for processing.
Right. But how do these coprocessors work in practice? Are they like little mini programs running inside Spanner?
Yeah, that's a good way to think about it. Coprocessors are essentially user-defined functions
Okay.
that can read and modify data within a transaction. They're
Okay.
going to be triggered by events, like
Mm.
read or write operations,
Okay.
or they can be called directly through a special API.
So it's like setting up tripwires in your database. When certain actions happen, your custom code springs into action.
That's a great analogy.
I try.
Yeah, and because coprocessors operate within Spanner's transactional context,
Okay.
you still get all the same guarantees about data consistency and reliability.
Okay, that's good. That's reassuring.
Yeah.
But I'm imagining building and deploying these coprocessors is probably not a walk in the park.
You're right. It's definitely more involved than just writing a simple SQL query.
Right.
You need to write your coprocessor logic, package it up,
Okay.
and deploy it to the Spanner servers.
Okay.
Thorough testing is also critical, of course,
Oh.
to make sure it doesn't break anything.
Yeah, of course.
Yeah,
Of
yeah.
course. So it's kind of like writing a plugin for Spanner, extending its functionality with your own custom code.
That's a good way to think about it.
I can see how that would be really powerful, but also a big responsibility.
It is, but that flexibility is one of the things that makes Spanner so versatile.
Okay.
And the best part is you can write coprocessors in a variety of languages,
Yes.
including C++, Java, and Go.
Yeah.
So you can use the tools and skills you're already familiar with.
Okay, I'm starting to see the potential here, but can you give me some, like, real-world examples of how these coprocessors are actually being used?
Sure. So data validation is a really common one. You can write a coprocessor that checks incoming data against a set of rules
Yeah.
before it's even written to the database.
So it's like a bouncer at the door of your database.
Exactly. It helps to ensure data quality and prevent errors early on.
That's really valuable.
It is.
What other interesting applications have you seen?
So data transformation is another really popular use case.
Okay.
So imagine a coprocessor that performs complex calculations or manipulations on the data as it's being read or written.
So it's like having a built-in data chef that can slice and dice your data.
That's a fantastic analogy.
I'll try.
Yeah, and this can be super useful for things like data aggregation,
Okay.
denormalization, or even pre-processing for machine learning tasks.
So coprocessors really add a whole new layer of possibilities to Spanner.
They do.
It sounds like Google uses them extensively in their own applications, too.
Oh, absolutely. AdWords, Google Play, and many other Google services leverage coprocessors for various tasks. They're a key ingredient in Spanner success,
Yeah.
allowing it to handle a wider range um, of workloads and use cases than would be possible with just standard SQL.
It really makes you appreciate the foresight of the Spanner team.
Yeah.
They build a system that's not only really powerful, but also incredibly flexible and adaptable.
They did, and it's not just about the technology itself.
Right.
The way Spanner is operated and managed is equally impressive.
Okay.
We're talking about a system that spans multiple data centers and manages petabytes of data.
Yeah.
The logistical challenges must be just mind-boggling.
Right. Do they have like a giant control room somewhere with people glued to dashboards?
I'm sure they have some pretty sophisticated monitoring tools,
Yeah.
but one of Spanner's most remarkable aspects is that it's designed to be largely self-managing.
Self-managed, you mean like a self-driving car for data?
That's a great analogy. They've built these intelligent control systems
Okay.
that can automatically detect and respond to all sorts of events.
Like server failures, network issues, or even shifts in workload patterns.
So it's constantly monitoring itself, optimizing performance, and like healing itself when things go wrong.
Exactly. And this level of automation is crucial
Right.
for a system as complex and geographically distributed as Spanner.
Makes sense.
It frees up the Spanner team to focus on higher level tasks like developing new features
Right.
and ensuring the overall health of the system.
So it's like a partnership, a collaboration between human ingenuity and intelligent automation.
I like that. Yeah, it's a good way to put it.
And this mastery is evident in how they've addressed this age-old debate of NoSQL versus SQL.
Yes, the battle of the databases.
Every few years, it seems like a new approach emerges, claiming to be the ultimate solution.
Right.
Where does Spanner fit into this ever-evolving landscape?
Well, it's important to remember that the NoSQL movement,
Right.
it emerged from the need for highly available and scalable systems.
Often at the cost of some of the ACD properties that traditional relational databases are known for.
So it was a trade-off between raw performance and data consistency.
In many cases, yes.
Okay.
But Google has always been kind of obsessed with both scalability and deconsistency.
Right.
And that's really reflected in Spanner's design.
Okay.
It really strives to deliver the best of both worlds.
So it's not a purely NoSQL or purely SQL database. It's something new.
You could say that, yeah. Spanner combines the scalability and flexibility of NoSQL systems with the transactional guarantees and query capabilities of traditional SQL databases.
So it's kind of a hybrid approach.
It is. It blends the best aspects of both worlds.
Okay. That makes a lot of sense, especially in the context of Google's massive data needs.
Right.
But the paper mentioned that even within Google, there were like different philosophies about how to leverage Spanner.
That's right. Early on, some teams, like the one behind F1, took a more loosely coupled approach. They built their own schema management and SQL query processing layers on top of Spanner's core key value store.
So it's like building a custom SQL house on top of a solid NoSQL foundation.
Yeah, it's a good analogy, and it worked surprisingly well. It showed that Spanner's transactional capabilities could be used as a building block for a variety of higher-level systems.
But eventually, Spanner itself embraced SQL natively.
Exactly. They realized that by tightly integrating the SQL engine with the rest of Spanner's architecture, they could unlock even better performance and flexibility.
So it's like they brought that custom SQL house inside the NoSQL foundation, creating this unified, seamless structure.
That's a great way to visualize it.
I try.
Yeah, and this tight integration has been key to Spanner's continued success, allowing them to optimize for specific SQL workloads and provide a truly powerful experience for their users.
Yeah, it's clear that the evolution of Spanner is a story of continuous improvement and adaptation, always seeking that optimal balance between performance, consistency, and flexibility.
I agree, and their approach to handling schema design further reinforces that notion.
Schema design, right? We touched on that earlier.
Yeah.
But it's clearly important when you're building Spanner applications.
It's crucial.
It's not just about throwing data into the database. You need to think carefully about how it's organized.
Exactly. A well-designed schema is essential for performance, scalability, and long-term maintainability.
Can you give me some concrete examples of how schema design can impact a Spanner application?
Sure. One key decision is how you how you represent relationships between different entities in your data.
Okay.
Spanner provides two main options for this:
Sure.
protocol buffers and interleaved tables.
Protocol buffers, aren't those usually used for, like, data serialization?
They are, but they're quite versatile. In
Oh.
Spanner, you can use protocol buffers to define structured data types within your schema.
Yep.
It's a powerful way to represent complex objects and relationships.
So instead of having separate tables for each entity, you can, like, nest them within each other using protocol buffers.
Exactly. This can be incredibly useful for representing hierarchical data
Right.
or one-to-many relationships, keeping related information closely linked together.
Okay, I can see how that would improve efficiency.
It does.
But you also mentioned interleave tables.
Right.
How do those work?
Interleaf tables are another way to represent relationships,
But-
specifically parent-child relationship.
Okay.
They let you store rows from different tables together based on a common key prefix.
So it's like organizing a library by grouping related books together on the same shelf.
Exactly. And when you need information about a particular book, you don't have to search the whole library,
Right.
just the relevant shelf.
Right, okay, that makes sense.
Yeah, and this co-location of related data can drastically improve query performance,
Right.
especially when joins are involved.
Okay, so I'm getting a sense of the nuances involved here.
Sure.
It seems like schema design in Spanner really requires careful consideration.
It does. It does.
What other factors should developers keep in mind?
So data partitioning is crucial.
Okay.
Remember those data shards we talked about?
Yeah.
The way you define your shard boundaries can have a huge impact on performance and scalability.
It's like slicing a pizza. You want to make sure the slices are roughly equal,
I like that analogy, yeah.
so everyone gets a fair share.
Yeah, you need to consider the distribution of your data
Right.
and choose boundaries that minimize hotspots and prevent some shards from becoming overloaded
Okay.
while others are sitting there idle.
So there's a real art to schema design in Spanner.
There is.
Are there any, like, resources or best practices that developers can rely on?
Absolutely. Google has a ton of documentation on best practices for schema design. They even offer tools to analyze your schema and pinpoint potential bottlenecks or areas for improvement.
That's fantastic.
Yeah, it's good to have a scientific approach to guide these decisions.
Right, rather than just guessing.
Exactly. And a well-designed schema can save you countless headaches down the road.
Yeah, I bet.
It can make your Spanner application significantly more efficient,
Right.
easier to scale, and much simpler to maintain.
I think you've highlighted a crucial point here.
Yeah,
Spanner's success isn't just about its innovative technology.
right.
It's also about the thoughtful principles and best practices that underpin its use.
Absolutely. It's a holistic approach to data management,
Right.
one that emphasizes both technical sophistication and sound design principles.
This deep dive has been really eye-opening. We've uncovered so much about Spanner.
Yeah, it's been fun.
Its inner workings, its clever optimizations, and the ways it addresses the challenges of handling data at a global scale.
It's a fascinating system,
Yeah.
and I think it really highlights the incredible innovation that's happening in the world of databases.
But even with all of Spanner's achievements,
Sure.
the paper hints at some interesting challenges that still lie ahead.
It does, yeah.
Oh, like what? I'm curious to know what hurdles even a system as advanced as Spanner still faces.
Well, one area they're actively exploring is supporting read-your-write semantics within transactions.
Okay.
Currently, Spanner has a strict ordering of operations within a transaction,
Yeah.
and they're looking for ways to make that more flexible.
So they're trying to give developers even more control over how transactions behave.
Precisely. This could unlock new possibilities for certain types of applications,
Right.
and it would also improve compatibility with other SQL systems that offer this kind of flexibility.
That makes sense. What else is on their radar?
Well, continuous query optimization is always a top priority. Finding the absolute best way to execute a query in a distributed environment is a constantly evolving challenge, especially as data volumes and query complexity continue to grow.
It's like a never-ending race to squeeze every ounce of performance out of the system.
You got it. And they're also investigating ways to seamlessly combine OLTP, OLAP, and full-text search capabilities
Okay.
within a single system.
So like a true one-stop shop for all your data needs.
Exactly. It's ambitious,
Yeah.
but given Spanner's track record, I wouldn't bet against them.
Right, they've consistently pushed the boundaries.
They have.
It's pretty amazing.
It is.
Based on what we've learned today, I have no doubt that they'll continue to innovate and shape the future of databases.
I agree. The future of data is bright.
Yeah.
And Spanner is certainly shining a light on what's possible
Right.
when you combine brilliant engineering with a deep understanding of data's potential.
This deep dive has been incredibly insightful.
It has.
But I'm realizing we've only just scratched the surface.
Yeah.
The paper mentions a few concepts we haven't had time to fully explore.
Right.
Like true time epsilon.
Yes.
And the role of the Spanner team itself.
Those are fascinating topics.
Okay.
True time epsilon in particular is one of the secrets behind Spanner's global consistency guarantees.
All right, now you've really piqued my curiosity. But unfortunately, it looks like we're out of time for this part of the deep dive.
Okay.
We'll have to save those intriguing details for part 3, so stay tuned. Okay, so we're back for the final part of a Spanner deep dive, and last time we left off on kind of a cliffhanger. You mentioned this true time epsilon and how it relates to Spanner's consistency, even across a globally distributed system.
Yeah. So true time epsilon, it's a really fascinating piece of the puzzle.
Okay.
To understand it, we kind of need to talk about true time itself first.
Okay.
Which is Google's globally distributed synchronized clock system.
Okay, a synchronized clock across multiple data centers. I mean, is that even possible?
Yeah.
We're talking about locations potentially thousands of miles apart,
Right.
each with its own local time.
Yeah.
It sounds like something out of a science fiction movie.
It might sound like science fiction, but it's a real feat of engineering.
Okay.
Each data center has a set of time masters,
Okay.
which are equipped with atomic clocks and GPS receivers.
Yep.
These time masters, they constantly talk to each other and to other servers in the data center,
Okay.
using some pretty clever algorithms to adjust for network delays and the tiny variations that naturally occur between even the most precise clocks.
So it's like a network of super accurate timekeepers, all constantly working to stay in sync down to the microsecond.
Pretty much.
But why is this so important for a database like Spanner?
So because it allows Spanner to assign globally consistent timestamps to every single transaction. This means that every event, every change, every read and write operation has a precise time associated with it.
Right.
And those times are consistent across the entire system.
Okay, that sounds insanely difficult to pull off.
It is.
How does this relate back to true time epsilon, though?
Right. So true time epsilon is basically a measure of the uncertainty in the clock synchronization.
Okay.
No matter how good your clocks are or how clever your algorithms, there's always going to be a tiny bit of uncertainty.
Right.
It's like a margin of error, usually on the order of a few milliseconds.
So like an acknowledgement that perfect synchronization is basically impossible.
Pretty much, yeah.
But how does Spanner deal with that uncertainty? Doesn't that mean there's potential for errors or conflicts?
That's where the real cleverness comes in.
Okay.
Spanner actually incorporates this uncertainty, this epsilon value, into its timestamping mechanism.
Okay.
When assigning a timestamp to a transaction, it adds a little bit of padding, effectively ensuring that even in a worst case scenario, timestamps won't overlap or conflict.
So it's like adding a safety buffer to prevent accidental collisions.
Exactly.
Okay, I'm really starting to appreciate just how much thought went into this.
Yeah.
Into ensuring Spanner's consistency. It's remarkable.
It's a really impressive system.
Okay, so true time and true time epsilon are just two examples of these innovations.
Right.
That makes Spanner so unique.
It really is a symphony of clever ideas all working together to create this system that's both powerful and reliable.
And speaking of working together, we haven't talked much about the people behind Spanner.
Right. So
how does the Spanner team itself manage this complex, globally distributed system?
That's a good question.
I mean, they've built a system that's designed to be largely self-managing, right?
Right, right.
We talked about that self-driving car analogy.
Yeah.
Spanner's constantly monitoring its own health.
Yeah.
Making adjustments, optimizing performance without someone at the wheel all the time.
Right.
But surely there's still some human element involved somewhere.
Of course. While Spanner handles a lot of the heavy lifting on its own, The Spanner team is still responsible for high-level tasks.
Oh,
They're the ones who develop new features,
right.
address any issues that crop up,
Right.
and ensure the overall health and stability of the system.
So it's a partnership between human ingenuity and intelligent automation.
Exactly.
Okay.
The Spanner team has really struck a remarkable balance there,
Yeah.
creating a system that's both incredibly powerful and surprisingly manageable.
Okay, so as we kind of wrap up this deep dive, what would you say is the biggest takeaway, like the key insight for our listeners?
I think the biggest takeaway is that Spanner really shatters this myth that you have to choose between scalability and strong consistency.
Okay.
For a long time, the prevailing wisdom was that you could have one or the other, but not both.
Right.
And Spanner really proves that you can have it all.
That's a powerful message.
It is.
It shows that with careful design,
Right.
clever engineering,
Yeah.
and really a deep understanding of the problem.
And a willingness to challenge assumptions.
Right.
Yeah,
You can achieve things that were once considered impossible.
absolutely.
That's something to keep in mind no matter what you're doing.
It is.
Whether you're building databases, writing software, or even just tackling everyday challenges in your life.
It's a good life lesson.
Yeah.
Yeah.
Sometimes the best solutions come from challenging those assumptions and pushing beyond those perceived limitations.
Absolutely.
Well said. This deep dive has been a truly incredible journey,
It has.
filled with fascinating insights
Yeah, a lot to think about.
and thought-provoking ideas.
Sure.
And I think Spanner is really a testament to human ingenuity.
It is.
And it's inspiring to see how a single system can push the boundaries of what's possible in the world of data.
I agree.
So on that note, I think we'll wrap up our deep dive into Google Spanner. We hope you've enjoyed this exploration as much as we have.
You too.
And until next time, keep those data fires burning.
And don't be afraid to challenge those assumptions.
Yeah, take care.